So I'm going to write out Bayes' theorem, and I'm going to talk us through it step by step. And with any luck, that steps then will make sense. Before I do that, let me write up this thing from the last section. The probability of B, provided A has occurred, is the common ground between those two, divided by the probability that A has occurred, because we've changed our total possible. So now let's talk about Bayes' theorem. Bayes' theorem says this. Let A1, A2, all the way up to AN, so I have not 1, not 2, not 3, not 4, but I have N groups, be a partition. A partition is just like partition dividers in an office. It cuts something into sections. It's a partition of a sample space. Remember, a sample space is our probability area, capital S, and we're going to let E be an event. So E is an event of the experiment and in particular, the probability of E has to not be 0, so it has to be positive. Also, the probability of any one of the partitions happening also needs to not be 0. So my partitions need to actually occur. They have to be a possibility. My event that I'm talking about has to be a possibility. And this is probability of AI, and 1 is less than I, which is going to be less than or equal to N. I is just, we call this an index. I is just a way to count. Instead of writing probability of A1, probability of A2, probability of A3, all the way up to probability of AN, all of them not being 0, I can just write it like this using this index. It's just a more grown-up way of writing something out quickly. And the probability is this. The probability of one of the partitions happening, provided I know that I'm in event E, is going to be this. It's going to be on top, I have my desired outcomes. The chance that that partition happens times the chance that event E happens, since I know that partition is the one I'm in. And what's the total possible? Well, it's going to be some additions. I could be in the first partition, but remember, E's occurred. So I have to talk about the chance of E when I'm in the first partition. I could be in a second partition, times the chance that I'm inside of that E in that second partition. All the way up, and we use this dot, dot, dot to mean keep on going in the obvious, clearly done way. Move this over here just a little bit and give myself some space. All the way up till the very last partition. What's the chance that I'm in the last partition where E is what's happening? This is what Bayes' theorem says. Let's look at what it looks like. Here's my sample space. Here's my event E. Here's my partitions. A1, A2, A3, A4, A5, A6. What's the chance of this one happening if I tell you that I know E has occurred? Well, it's not all this stuff outside. It's all the chance that I'm in A1, or excuse me, A4, and still inside E. So how do I calculate that? Well, I figure out the probability of me being inside of A4. I multiply that by the probability of me being inside of E when I'm inside A4. And then I have to divide by the chance that I'd be here, or here, or here, or here, or here, or here. Because that would be my total possible. I could have landed anywhere in this picture.